Hello, everybody. Welcome at our last session, which is community talks. Tonight, I have Ekaterina Fedotova with me. She will be presenting her presentation about field visualization in R. So, Katya, the floor is yours.
Thank you. Hi, I am an energy researcher, and my working group is working on two kinds of problems. The first one is adaptation of the national power industry to the changing climate, and the second is supporting of the energy transition on national level. That means that we are working on an intersection of three different big research and development sectors: energy systems models, climate science, and data analysis. And we should keep in mind that our energy engineering peers are often quite skeptical about the climate change. And we should keep our presentations of our climate findings as simple and as persuading as we can. And actually, that is approximately what I was told when I was demonstrating my first findings in our area, in our laboratory. Our professor told, yes, that is all good and right, but could you please to be more precise, because all these shadings and details, they're a little bit confusing. Look, that is what we have as state of the art. That is what our commercial GIS systems present. And well, it looks and it works quite good. We need distinctive and clear picture. We need pictures, we need graphics that are clear, that are appealing, that are eye-catching. And all these field gradings and field shadings and a lot of details, that is not what you need to keep attention. You need some more simple, some more contrasting contour plots with distinctive colors for each level of values. And that is better to overlay it with a simplified geographical map. And of course, you need also a simple and reproducible data operating workflow. And last but not least, the plot need just be beautiful. Let's see what it look like in reality. Let's take SMIP6 simulation data. That is data of global climate simulations, which lie in any knowledge at the moment, and almost any knowledge which we could have about the future climate. Let's see on the Africa. The matter is, the bigger is the region which you are looking with global climate simulations, the better. And we will take moisture in the soil to have both positive and negative changes. And that is important from programmatic point of view, that the data initially are in white format. Let's fix some technical parameters to compare different types of visualization against each other. And let's go first. We have image, just the most basic visualization function. That is great if you need to have a look yourself, which data, which picture do you actually have. And the one small disadvantage, the one small drawback is that you need a little bit repeat yourself and draw the legend manually. But if you have white formatted data, image works perfectly for you, but not for your peers, because, well, the picture itself is rasterized. There are a lot of details and it doesn't look appealing enough. So let's go for white to long transformation. That is purely technical stuff, but that is a lot of pain if you need to do this transformation, especially taking into account that data which are designed for image are not very, you need some additional transformations. their technical details. And when you transform from wide to long format, that is a lot more degrees of freedom. For example, you can simply filter out the data which do you not need. We are interested on soil, that is, so we are not interested in ocean. And there are simple, very simple and transparent approach. How can we filter out ocean points, geographical points which correspond to ocean, not to soil? And let's go further. The next basic function is a filled contour one. But the problem is that the filled contour in its original state is quite strict about data formatting, about data coordinates, data sending, descending. And that is why better to use raster version of filled contour, which gives quite nice picture. But unfortunately, there are some troubles when you are trying to overlay this data with map that is connected with some discrepancy between subsequent application of filled contour and other graphic functions. Of course, you can fix it, but it requires quite a lot of work. That is why, well, I am not a big fan of this approach. And the second, the third method, there are different functions of ggplot2. The most, the older approach, that is geometry tile, and actually again, that is raster image, that is raster result. But an advantage as compared with basic image is that you can use quite sophisticated geographical transformations in ggplot, and such transformations are still inside the base, the ggplot2 graphic system. So you do not need any additional packages. So that is a point to remember about when working in ggplot2 with spatial data. But there is a better function as compared with geometry tile, quite an old one. There is another function which designed exactly for our problem and which was developed less than 2 years ago. That is the result of default of this call with default settings, and it still looks quite promising. When we will use custom palette, it is better. And if we put everything together, including maps and coordinates transformation, then the result is perfect, almost perfect, because there are unfortunately some lines on the border of your region which we do not need. There's lines between different between areas of different variable values. This line is meaningful, and this line well, is quite an artifact. There is a workaround for it, but that is still a workaround. And to my personal view, LATTICE gives the most interesting result. It follows just the basic LATTICE package, an alternative built in our graphic system. LATTICE follows exactly the classic layer logic, which is native for these applications. And besides, there are some powerful extensions which use LATTICE as a graphic engine, such as SPPplot or raster-viz. So to put it together, image is great if you need easy and quick visualization for yourself, and ggplot and LATTICE give you great opportunity to present your data in the most beautiful way. And what can be concluded from the whole workflow? Well, each practically driven data-related request can be covered in R with quite reasonable approaches. And moreover, each task can be performed in different, equally correct ways. And that is great. Such a diversity gives you a lot of possibilities. So essentially, that is all. Technical details are available in my repository on GitHub, and I will try to explain them in a further post on my blog. So if you have any question or comments, please contact me or drop an issue on this repository. So many thanks. It was a pleasure to present here.
Okay, thank you, Ekaterina. It was a pleasure to have you here tonight, and I really liked the presentation. Thanks for putting up those links. I hope people can reach you easily thanks to that. And thanks for your time, and see you next year.
Many thanks, Martin. See you.